Morning, and welcome to the second to the last session in this year's Signal Innovation Showcase series. I'm George Seifers, Editor-in-Chief of Signal Magazine. Next up, we have Zach Benefield, Senior Security Engineer with Tenable. So Zach, welcome to the podium, sir.
All right, everyone, it's a pleasure to be here this morning. Happy to see everyone in the audience. So today we're going to be talking about building a resilient DevOps framework, or DevSecOps framework for DISA and the DoD. I'm Zach Benefield. I'm the Federal Security Strategist at Tenable, and that just means that I've been doing this for way too long and I've seen too much stuff. So when we talk about DevSecOps, I tried to think about this as simply as I could, right? I was like, what does DevSecOps actually mean? And when I broke it down, it meant, it's a process to enable security, development, and operations to work together in a way that allows rapid development while maintaining security and operability of operations. So to put it simply, DevSecOps equals faster development with built-in security and better collaboration. And this is really important because in the old days of software engineering, or really just trying to get anything out there, we were real slow and we made a lot of mistakes, right? What you would do is you would build all of these features together, and then you would put out these big releases, and inevitably you would break something. So with the inception of things like agile development and DevSecOps, we were able to start doing little bitty chunks of development. So you were no longer building all of these big things where one thing might break everything. You were building little functional pieces, and that way if something did break, you could quickly identify it, and you were speeding up the release cycles of your releases. So it wasn't this big monolithic thing that you were dropping on the industry. It was a functionality, it was a capability, it was something that an end customer needed right now, and you could get it to them in a much more quick turnaround time. So previously, everything was under waterfall, right? And we would see iterations of up to 6 months sometimes of software development, right? Like I've got to wait 6 months before I get this thing that I need. So under DevSecOps, we moved to both DevSecOps processes and the agile development. And this sped things up because it wasn't linear and sequential like waterfall. It was iterative, right? And it was continuous. You continually developed based on what the customer needs, the field's needs, the capability of the product needed, and you kept that moving as you released each thing. Waterfall also had security as an afterthought, right? So how many times has an application been shipped out and then you scan it and you're like, hey man, there's a vulnerability in there that's 3 years old from this library. So DevSecOps work to actually build that security into the development process so that you are no longer stuck with this post-finding that you've got to remediate now at 10x the cost, right? Waterfall made changes hard to accommodate because so many things were linked together and they weren't kind of segregated, working separately, linked together on the back end. They were truly tied together. And so to make a change, you might have to make a change across 4 or 5 different elements of the product instead of this one capability change. Whereas DevSecOps introduced a rapid change and rapid feedback, right? So I could get this thing out in 2, 3, 4 weeks and get feedback on it, modify it, get it out again, continuously develop on it. So DevSecOps thrives on rapid feedback loops, automation, and collaboration across development, security, and operations, which are inherently at odds with the rigid phase-driven structure of waterfall. It was a complete 180 on the development cycle. As you're looking at the DevSecOps process, you've got to take the shift left into account, right? And we're losing HDMI for a minute, but that's fine. We'll just we'll play with this and get it a little more secure. So you've got to take that security and shift it left. I'm no longer getting applications complete and then scanning them. I'm working with my development teams as a security professional to go, hey, that thing you're developing has this library in it that's vulnerable. Let's see what else we can use, right? I'm not telling you what you need to use, but I am telling you we can't use that. So you need to either patch it, find a different library, but we're taking that security mindset and we're putting it into the development cycle. You'll see on this graphic, the continuous integration and continuous delivery, so you'll commonly hear that as CI/CD. So CI/CD development, CI/CD pipeline, that's just a piece of this process. It's the build, test, release, deploy sections. And typically security would come in after this under the old waterfall mechanism. So when we're looking at DevSecOps, we want to start building security into these elements. Traditional security techniques, they're often really ineffective when you're looking at the way that these things are developed, because the technology has changed fundamentally. We're no longer looking at monolithic apps anymore. Now we're looking at things like Docker containers, things that have had core elements stripped out that a traditional VM would have. And so you can't say, well, let's just run a Nessus scan against these containers, because more often than not, they've had the authentication stripped out, they're missing critical libraries, dependencies won't fire. And so you have to use the tools that are designed for these types of environments. You've got to use the tools that are designed to understand these types of deployments, these types of developments, and you've got to speed it up by incorporating it into that CI/CD process. So it's not good enough to start figuring out your vulnerabilities after the fact. You've really got to build that into your process. So hey, I'm going to build, I'm going to scan, I'm going to test, I'm going to scan, I'm going to deploy, I'm going to scan, right? You've got to be continuous and thoughtful with that scanning mechanism and use tools that understand these types of platforms that we typically see within the DevSecOps pipeline. You've also got to automate that security testing. So the amount of people that I see that are still pointing and clicking is crazy when you look at all these different things that you need to do as part of DevSecOps security, right? Secure coding, threat modeling, secure transfer, secure configuration, security scanning. It's too much to have a human sitting there doing this over and over and over. So you need to find tools that can be built into your pipeline and can become automated as part of your workflow, right? I shouldn't be spending 2 hours figuring out my vulnerabilities as part of my pipeline. I need it to be a 30-second process. Hits it, gets assessed, somebody looks at that assessment and goes yay or nay, keeps moving onwards, right? And that has to be a continuous process with a feedback loop, right? So security needs to be able to go, hey, development, we caught this thing 10 minutes ago as part of your process. You can't push that out, or even have it automated and say, if this thing is caught, fail the build. And that way the security team never even has to touch it. The developers know, or block the deployment. Make sure it doesn't go out into production so security doesn't catch it afterwards. Because if they have to catch it afterwards, that's defeating the entire purpose of DevSecOps. So you need those tools that are automated and work as part of that pipeline to really become effective in this development cycle. So you got to secure the dependencies and the container images. When we're talking about containers, there are what's known as base containers, right? Base images. And that's like, I want to build this application that has CentOS dependencies. I'm going to start with a CentOS base image. If I don't start by looking at that base image and securing the vulnerabilities that are within it, everything I build on top of that is going to propagate those vulnerabilities over and over and over. If I build 15 applications, I'm now propagating those vulnerabilities from that base image 15 times over. So you've got to start from the base image and remediate those vulnerabilities before you start pushing them out to your environment through those subsequential images. You also need to regularly scan those containers for vulnerabilities, and that just ties into the previous slide, right? Always assess in multiple places sometimes within your CI/CD pipeline, right? Sometimes you may want to have both a test and a prod pipeline. Make sure you're assessing in both. Make sure that no changes are happening in between, right? I'll often see replications where it's test registry, test pipeline, test environment, and things will change between that and prod because somebody will come in and be like, oh, we need this change, but not send it through the test pipeline. So make sure that you're incorporating it into both sides. Understand the third-party libraries and how they introduce risk, right? So this is something that we generally didn't have to deal with before, but now has become really rampant within things like containers, because you can very quickly add a command within a container that's going to add packages, right? Before, it was like, okay, well, you've got a team of developers that are working on this thing for 6 months and they know exactly what's in this container. But now I might have a developer sit down and go, yeah, I need Python 2.7. And they'll very quickly add a layer into that container that adds Python 2.7, and now you've introduced all the vulnerabilities that are associated with that. And it's not a matter of months that this has happened, it's a matter of minutes. So you've got to understand those third-party libraries, how they introduce risk in a really granular way. You know, being able to output things like S-bombs, being able to cross-check it against an approved product list. Those become critically important in this process. And then you've got to understand what's occurring at those container layers. So when you're doing container development, every single thing that you add to that container is going to add a layer. And it basically just builds on itself, right? The container's like, all right, I run layer 1 first, I run layer 2 second, third, fourth. That's how I do my patching. That's how I do my installs. That's how I add files. Everything within a container is built on layers. And so you've got to understand what's happening at that layer level for different reasons. Some shops will delineate the layer level to teams. So you might say, hey, team A over here is responsible for layer 1 through 10 because that's at the base image. Team B over here is responsible through 11 through whatever because that's after the base image they're building on top of. So if I understand what's happening in those layers and where that risk is introduced, I can go, hey, this is in layer 4. Team A, this is yours. Please remediate this so that Team B doesn't inherit your vulnerabilities, right? It also becomes critically important when you're looking for things like compromise. So I was previously an exploiter before coming to Tenable, and I would love popping containers because I could put a backdoor in, and then every time you spin up a new container from that container image that I popped, you're giving me a new backdoor. So one of the things that we did with our secure enclave platform is actually show you what's happening at the layer level and what vulnerabilities are introduced from that level. So you can drop that down and go, okay, this layer installed all these packages introduce these vulnerabilities, but you can also look at the commands that are being run. So I don't know if you can see it up here, but this particular command is doing an apt-get update, apt-get install, and it's installing a bunch of packages. If I find that someone is installing a backdoor or they're installing packages that aren't on the approved product list, you can then grab that command and search all of your layers across all of your container images to eradicate that threat and lower your risk. So it becomes a really effective tool for proactive threat hunting and just widespread risk reduction, right? Continuous monitoring of risk. Everything in DevSecOps should be continuous. That cycle should just be continuously monitored, continuously moving, that feedback loop continuously going. And you've got to understand what's going on with the risk of those vulnerabilities within the containers. So one thing that Tenable does really well is research. We're as much a research company as we are a software company. I know everyone knows this as ACAS. They're like, you guys are the guys behind ACAS. And that is our bread and butter, but secondary to that is our research. So if you look at your ACAS instance, if you look at any of our other products, you're going to see this thing called VPR. And VPR stands for Vulnerability Priority Rating. So what we do with that is we actually take the CVSS scoring of vulnerabilities, you know, the 1 to 10 that says how bad it is, and we go, that's a 7, but based on threat intelligence of widespread exploitation, dark web chatter, new proof of concept, things like this, this is not a 7, this is a 9 or a 10. This is very likely to be exploited. So our research team is constantly working on that with multiple threat intel feeds, 170 data points of data that's basically just always being calculated against every single vulnerability to say, yeah, this is a 9 or a 10, this is a 7, this is a 5, right? This hasn't been exploited in 2 years, but the vendor hasn't updated their CVSS scoring. So that's one of the things that we like to bring to bear with all of our products to understand true risk posture. You know, if I have 5 minutes to knock out vulnerabilities, I can pinpoint my top 3% of vulns through that VPR scoring. One of the other things that I wanted to talk about is the actual mechanisms behind threat modeling when you're in design, right? So when you're in the design phase, you've got to understand not just what's coming, but like what might happen. So when you're designing, you've got to look at secure code processes. You got to look at secure design. What I see a lot of times in DevSecOps, really in all development, is people start with an idea, but they don't formulate it out to the 10 points that it should be, right? So they might have 3 points, 4 points, but they don't look down the line to say, all right, well, here's the features and functionalities and how they should work together. How can we make sure that these things don't break each other? How can we make sure that these things don't make each other vulnerable, right? So you've got to look at things like your crypto within your containers. You've got to look at things like how it's authenticating, how it's networking, what it can communicate with across the network before you ever start building. You know, you've got to get really in depth with that design phase, and that's going to help you remediate a lot of those vulnerabilities down the line. If I can go to something like the DoD software factory and start pulling down images and taking a look at what's vulnerable or not in those, I can start compiling the different packages, libraries, things like that that I can use within my containers. So you want to be really mindful of that in the design phase, so that you can truly shift that security mindset to the left instead of reactively going after these vulnerabilities. So it just becomes really critically important to build security in as far left as possible, but also have it in each step of that CI/CD pipeline, each step of that DevSecOps process, and to use automated tools that are going to do things for you. You know, I don't need an analyst sitting there going, yeah, that's a pretty bad vulnerability, we should tell these guys. I need a tool that's going to go, that's a pretty bad vulnerability that security has told me is not allowed in here. Go ahead and fail this build so that the developers know I need to go fix this before we roll it out to production. All right, questions? Cool. Thank you guys for having me. Thanks.
Thanks, Zach. That was a great presentation. Next up at 11:30, we have John Eubank talking about the vDetect. So come back and join us for that.